Everyone, I hope everyone is safe and doing good. Welcome back to my channel Trick or Treat with Mathematics. So in today's video, we will be seeing laws of logarithms. These laws are basically can be derived from the primary concept of logarithm. So I will show you how we have come to these laws as well in today's video. A small disclaimer is that I will first try to help you understand the laws using base 10, log to the base 10. However, these laws are applicable to any basis. The first rule of logarithm is for any real number x, we will say that log 10 to the power of x to the base 10 is x. How do we prove this? For example, I will ask you a quick question first. What is the meaning of this? Okay, leave this beside. What is the meaning of this? We will say that by definition of logarithm, we know that to what power must 10 be raised in order to get 7. That means, in short, this is 10 power of x is equal to 7 and we are trying to find x here, right? In the same way, what do you think about this? To what power must 10 be raised in order to get 10 power of x as the value, right? So can I not write this as, here I am not taking any variable, just taking question mark, and this is equal to 10 power of x. Okay, this is the power that we need to find out. So to what power must 10 be raised to get 10 power of x as the value? So what is the power here? Using laws of exponents, we know that when bases are equal, we equate the power. Right? We equate the power. So here, what is the base? 10. And what is the power here? The RHS side has the power as x and one of the other sides as LHS has question mark. So can we not conclude that here the question mark value is x? Yes. So, can we not say that this entire value is x? Because 10 power of x is nothing, it's equal to 10 power of something. So, when bases are equal, we equate the power. So, what is that power to which 10 power of 10 must be raised in order to get 10 power of x? Nothing but x itself. That is the first law of logarithm, that is 10 power of x to the base 10 is equal to x. Here please note that the base and the number itself is equal, that is n and b are equal if we assume n as the number and b as the base. Okay, so this is the first law of logarithm. Now using that I have written few examples here. Let's try to decipher these. First example is log 10 to the base 10 and the power here is 3.7. Here x is 3.7. So answer will be nothing but 3.7 only. Right. Next is log. How do you write this? We will write this as log 1 by 1, 2, 3, 4. So can I not write this as log 10 power of minus 4? Right. Because it's nothing but 0.0001 is nothing but 1 by 1000, right? So I will write 10 power of minus 4 to the base 10. Again, base and the number is equal, so we'll get minus 4 as the answer. And here, how do you write this? First, keep the base as is. First, try to get this in one form. That is 10 power of 4 into, this is to the power of 1 by 5, right? So we can write this as 3 by 5. Yes. And now here using laws of exponents, a power of m into a power of n is equal to a power of m plus n. So we get here as log 10 and this 4 plus 3 by 5. This is nothing but log 10 23 by 5. So answer is 23 by 5. Rule 2 states that for any real number x is greater than 0, that is positive integer, 10 to the power of 10 x to the base 10 is x. So now let's see how to prove this. Know that By definition of logarithm, 10 power of x is 7. So how do we convert this by definition of logarithm? We'll write this as log 7 to the base 10, and this value is nothing but x. And log 7 to the base 10 in calculator will be something like this, 0.8451. Let's try to get this in the form of this. What is the meaning of this? Our LHS here, he's saying that 10 raised to the power of something will result in something else. So by definition of logarithm, we know that log x to the base 10 will result in log x to the base 10 only, right? In this situation, if we substitute 7 in place of x, what do we get? We get that as 10 log 7 to the base 10, right? So we want to know what is the value of this. What do we get here? We know by definition of logarithms that log to the base 10 to the power of p is equal to log 7 10. Can we not say this? I am assuming this as some value p. Okay, now this is x here, the exponent, you say 10 power of some exponent, and this give you p. Value is p. If you convert this into logarithm, that is, what power must 10 be raised so that we'll get the value as p? That is the definition, right? So using that definition, can we not write log as here and 10 we not take base as here, and can we not say p? And what is the power here? Log 7 to the base 10. So what do you get from this? You get from this that p is equal to 7, right? And if you see here, the same concept I have applied. I have said that 10 power of x is 7, and we know that x is log 7 to the base 10. Okay, and what I have done is I have taken this 10 log x to the base 10 as some value. Again, I am saying that this is x only. Okay, and then I have converted that into logarithm. What did we get when we convert exponent to logarithm? We saw that this value is equal to this value. Here, if we assume that this has p, we get p is equal to 7 itself. So based on this, we can conclude that 10 raised to the power of log x to the base 10 is x itself. That is the number that will result when you raise a power to the base 10 here, or any base for that matter. Okay, so this is another rule. Based on this rule, what are the values of these? 10 log pi to the base 10 will be what? Pi. And 10 log x square plus y square to the base 10 will be what? X square plus y square, because answer is equal to x only. Log 10 log to the power log 10 to the power of 3x cubed to the base 10 is 10 to the power of 3x cubed. Okay, so this is another rule of logarithm. The next laws of logarithms are, I have clubbed these two so that it will be very easy for you to understand and relate what exactly we are dealing with. Here we are saying that for any real numbers x is greater than 0, y is greater than 0, log xy to the base 10 is log x to the base 10 plus log y to the base 10, and log x by y to the base 10 is also log x and log y. Now, how to prove the first one? Let's assume that x is what? Can we write this using rule 2? And can we not write y also like this? Right. So, I want to multiply these two. What will happen if we multiply these two? We'll get xy is equal to 10 log x to the base 10 into 10 log y to the base 10. Right? And what is this? A to the power of m into a to the power of n, using laws of exponents, and we get a to the power of m plus n. So can we not write this as, yes. Now Okay, this is again in the form of 10 to the power of p is equal to n, right? And here we are converting an exponent into logarithm. How do you find the power of p when it is raised to the base 10 and that results in n using logarithm? So what we'll do, we'll take this as base. So we'll get log to the base 10 and this is the result, xy is equal to log x to the base 10 plus log y to the base 10. So this is nothing but this. This is how we prove that for any real numbers x and y greater than 0, log xy to the base 10 is log x to the base 10 plus log y to the base 10. Okay. Similarly, we can prove the division also. Division will be converted to subtraction. If you remember, I have told you that main application of logarithm was to ease calculation. That is, in this case, multiplication is converted to addition and division is converted to subtraction. And the concepts are very simple. Just the reason being that multiplication is repeated addition and division is repeated subtraction. I will clearly explain to you in one of my previous videos. I will link it up here. Okay. Now, using this only, x and y as, let's try to divide these two. Here we are what? We are multiplying. Now here we are dividing. Now what happens if you divide x by y? We get this as 10 base 10 by 10 to the power of log y to the base 10. Right? And we can say that x by y is equal to 10 to the power of a power of m by a power of n, and we know this is nothing but a power of m minus n, right? So this will be 10 to the power of log x to the base 10 minus log y to the base 10. So using the same concept as this, we can conclude that log x by y to the base 10 is log x to the base 10 minus log y to the base 10. Okay, so this is how you prove that for any real numbers x and y greater than 0, log x by y to the base 10 is log x to the base 10 minus log y to the base 10. In these two concepts, now let's try to solve a simple problem for you. Log xy by z to the base 10. First, we will assume that this is one unit and this is another unit. Okay, log x and log y. What did we know when you divide 2? Is in the form of this. So, can we not write this as log xy to the base 10 minus log z to the base 10 using the rule 4? When we divide or when we have logarithm in the form of log x by y, we get the result as log x to the base whatever it is and log y to the base 10. So, after this is the form of rule 3. So, can we not divide that as this? X to the base 10 plus log y to the base 10 minus log z to the base 10. So, this is the result after applying these two rules. Okay. Next rule is for real numbers as x and n with x is greater than 0, log x to the base to the power of n to the base 10 is equal to n log x to the base 10. How do we prove that? Let us say x is equal to 10 to the power of log x to the base 10. Right, this is using rule 2. We know that 10 raised to the power of log x to the base 10 is x only, right? So, I will add the power here. Okay, now using laws of exponents, we know that a to the power of m whole to the power of n is equal to a to the power of mn, right? Apply this here. So, how do we get 10? N into log x to the base 10 is equal to x power of n. Right. So, now the concept of logarithm here. 10, this is the power and we should get x power of 10. So, how do we convert this into logarithm? We'll say that log to the base 10 x power of n is equal to n log x to the base 10. If we assume that 10 is the base and this is the exponent and this as the result. Then using the concept of exponent, we'll convert this into this. So did we not prove this? Yes. So log x to the power of n to the base 10 is nothing but n log x to the base 10. So using this concept, now let's try to solve these problems. So the first problem is this. How do you write this, or how do you simplify this? Using rule 3, can we not say that this is the result? Because log xy is equal to log x plus log y to the base 10. Right. Now using rule 5, that is this rule, can we not say this is nothing but this? Right? So this is how you simplify this into this. Now let's try to simplify this. First what we'll do is we'll convert this into this using log 5. And then same thing what we'll do is we'll do x square minus z cube whole power of 4. Right. And now using the division rule that we have seen, log x minus log y to the base 10 will be log x by y. So log y square by x square minus z cube whole power of 4 to the base 10. So this is how you use the rules of logarithms in any application problems. So as I told you in the introduction, we have seen all the laws up till now to the base 10 by considering the logarithm to the base 10. But I have also told you that these can be considered, or these laws are applicable to other bases as well. And if we call that base as b, where b is greater than 1, I have shown you why base should be greater than 1 in my previous video. If to the base b and for b is greater than 1, then all the laws that we have seen so far are applicable. Here what I have done is I have just put base as b instead of 10. So for x belongs to R, all the conditions remain the same, but for x belongs to R, log b to the power of x to the base b is x. This is the second law again, x plus y, and x by y is x minus y, and x power of n is n log x. Okay, so these are the rules of logarithms that are applicable to any basis. Right. So with this knowledge in mind, I would like to go or take a step forward to deduce our next rule. For example, let's say x is equal to a to the power of log x to the base a. Right? This will give you x only, no? Based on this rule. Okay. Now let's try to apply log to the base b on both sides. What will happen if you do this? We'll get what? Log x to the base b is equal to log a to the base b, and a will be raised to power of x, comma x by a, x to the base a. Yes. What will happen? Using this rule here, can we not take this in front of log? Yes. So we'll get log x to the base b is log x to the base a and log a to the base b into. Right. So what do you understand here? We understood that log x to the base b can be written as log x to the base a and log a to the base b. So this is our next rule. And here x is greater than 0, a and b should be greater than 1. This is one of the rules that is extremely important in case you need to deduce the value of logarithm to any other basis. For example, let's see one problem using that rule. Imagine a situation where you have your calculator with you, okay, and I will ask you to give me the value of log 7 to the base 9. You have your calculator handy, but you don't have a log table. Okay, and I ask you to find the value of this, and remember As I told you in one of my previous videos, the calculator will have log to the base 10 simply because to the base 10 is the logarithm, right? So, how do you find this value? What we do is we'll convert this into log to the base 10 and then we find. This is where this rule will come into picture. How? First I'll write this as log 7 to the base 10 into log 10 to the base 9 using this rule. Yes. Right. And how do you convert this? Log 7 to the base 10, you will get this value into 1 by log 9 to the base 10. That is, this is the inverse of this. Okay. In short, we can say that log A to the base B is 1 by log B to the base A. Okay. Using this, we have converted this into this. Okay. So, this is how you'll get the value of log 7 from your calculator. You'll get the value of log 9 from your calculator. You'll take the inverse of it and multiply. This is how you'll find the value of log 7 to the base. You may ask me, how did we get this rule? From this concept only. Let's try to take x as b here. Let's see what will happen. Log b to the base a into log a to the base b. From this, what is the value of this? We get log b to the base b when you assume x is equal to b. Right. And you know for a fact that log a to the base a or log 10 to the base 10 or log b to the base b is 1 because the power is 1. So, we will get log b to the base a is equal to 1 by log a to the base b. That is nothing but log b to the base a into log a to the base b is equal to 1. Okay, that is how we have written the inverse. And from here, we have deduced the value of this and we convert it into this. So, this is about laws of logarithms. I have clearly explained you how we can deduce these laws of these rules from the basic concept of logarithm. So, I hope you understood each and every law and I hope you will use these in solving your problems. So, if you have any questions, please leave a comment below or drop me an email so that I will be able to answer you. I hope you understood today's lecture. If you like my video, I request you to please like, share and subscribe to my channel and ring the bell notification down below so that you will never miss an update from me. If you have any questions, please do not hesitate to leave a comment below and I shall see you all in my next video. Till then, stay safe and be happy. Bye.